You can have the best battery, but you still need to focus on the safety. Talking with GM, they say factor number one is safety. So safety can be improved by implementing current interrupt device. Here it's a cylindrical battery, but you have also prismatic batteries. To implement gas release vent or a shutdown separator and also a separator coating. Separator coating will prevent dendrites from between the anode and the cathode, especially if the anode is a lithium metal. Center spin also, and thermal stable active material. This is one big problem for the safety. Choosing the right material for the anode and the cathode is very important. Stable electrolyte also is critical. You don't want to have a flammable electrolyte, so sometimes they're adding additives to prevent fire. And also protection tape on the weak points, aluminum and nickel tab. On the design for power performance point of view, by choosing the material cheap but also safe, nickel, manganese, cobalt, or nickel, cobalt, aluminum can do the job. Increase the electrode tab numbers, and also, and very important, decrease the lower internal resistance of the battery to prevent overheating. So you can do that by having good coatings of your materials on the current collector and using nanomaterials in the system. Fully automated battery manufacturing process is the key of the mass production and the low cost of a battery. It's all start by pretreatment of the powdery material, so the active material, and the binder and the carbon binder to improve the electronic conductivity of your film. So a dry mixing and a composite synthesis. So then you do the dispersing of those materials in a solvent to create a kind of slurry, and before doing the coating on the current collector. So all this is done in an automatic machine here that can run several hours, if not 24 hours a day. You can also coat both faces to save room and to have a better efficiency. You still need to evaporate an NMP, so due to environmental problems, NMP is evaporated, but condensated, recuperated, and recycled here. And to densify the surface, you have a final calendering of the cathode before doing the assembly of the battery itself, kind of sandwich, packaging on cell manufacturing, and first electrochemical cell testing. So during the conference of SAE, I talked to different people, engineers from LG Chem and GM about their battery. So LG Chem Korea is providing presently the cells to GM, where GM is doing the assembly of the module with the electronic system, cooling system, etc., before assembling the final T-shape battery for the Volt. The Chevy Volt, it's a lithium polymer battery from LG Chem cells. It has a power of 36 kilowatt. The weight is quite significant for such a vehicle, for around 40 pounds, and the dimension 33 by 64 inches, and it has more than 200 cells from LG. The autonomy is reasonable, 40 miles on full charge. That will allow you to commute each day. But it still has a 1.3 gas engine inside, so you still have a tail pipes. You are still filling the car with some gas time to time to prevent a fully discharge and to be left on the road, sometimes in the middle of nowhere, especially in Canada. For the charging, I was very surprised. On a 110 volt outlet, it takes 8 to 10 hours to fully charge the battery, whereas on a 240 volt outlet, only 2 to 3 volt. So you can have some charging system installed in your garage at home to fast charge your battery. The second vehicle, it's the Nissan Leaf. This one is a 100% battery electric vehicle. It doesn't have any small internal combustion engine, only batteries and electric motor. It has a lithium polymer battery made from a consortium between Automotive Energy Supply Corporation, Nissan, NEC, Energy Device, and Zama in Japan. The power, it's around 24 kilowatt-hour, and he has 48 modules of 4 lithium-ion, we say modules, cells, for a total of 192 cells. So you can see here the modules and the cells pile up, and it takes, it's in the floor of the car. The car is quite low, and it takes some room in the trunk too, but you can still not fold the seats like a normal car. The autonomy is much bigger. It's 100 miles on full charge, 160 kilometers. But here I was very surprised too, the charging time on the usual outlet at 110 volt, 12 to 15 hours. And on a 240 volt, 4 to 5 hours. So it's okay during the night. You can charge your car. So the Volt, the Nissan Leaf, and here it's the Think. You also have another one, I think it's from Mitsubishi. It's a small car. So developers, chemistry used by the developers, and expected vehicle, done or not done. Some of them are still in the pipeline, but you can see that the OEM, the car manufacturers, are actually have a large choice of suppliers. Mercedes-Benz with the model S40, it's more an hybrid vehicle. It has a lithium-ion battery made by Saft and Johnson Control. It's located on the front of the car, and it helps to provide power when needed. So once you have the car, you need the charging system. Charging system that was on display during the SAE conference, it's mainly the plug-in. So you have a cable charging with plug-in, or in the future, or on the testing right now, it's the wireless charging with an inductive current created by a magnetic field. So the car will park on the lot where you have a kind of a magnetic field with this system that will recharge the battery by an inductive current. Presently, to my knowledge, you have available on the market Aero Environment charging system and General Electric. I think Eco Totality is also developing some system that they want to sell in China. And the charging smart grid. So during the day, you will have different places where you can charge your car. At home, you will have the system incorporated in Canada. I don't know in the States, but now we are having the price of the hydro is cheaper during the night. So charging the car during the night will be beneficial. Also fleets like UPS and US Post or Canada Post. Electronic system incorporated in the car will tell you where is the nearest station where you can fast charge your car, especially if you are commuting or driving between two cities. And smarter cars and parking and charges too. This is something that should be implemented. So standardization needs an implementation. To fill the need of electrification of transportation, there is, like the egg and chicken, you will need to have this involvement of public and private investment to build the infrastructure for charging, and also the cooperation between governments and industry in battery manufacturers, OEM, car manufacturers, and power utility companies. They should work together to create this smart grid for people actually to adapt this system. Gasoline will still be present, but if we want to have the electric vehicle adapters, we need to create this one. Implementation and regulation, common legislation between industrial countries there is this CAFE regulation already existing in the US, so that can be an example. In Europe too, they are more strict about CO2 emission than we are here in North America. And regulation should be based on recommendation from independent organizations such as SAE, Society Automotive Engineers, IEEE, STM, EPA, NHTSC, and more. They should work all together. So in summary, what we can remember is that there is an urgent need to address the CO2 emission and oil dependence by actually implementing more electric vehicles on the market. USA and China will be the major EV markets in 2020. India is growing too, and Europe actually is taking some measure to implement electric vehicle adoption. We already have 15 years of R&D testing, continuous improvement from batteries companies so far. So the product is here. It's a question for the car manufacturers to adopt it. Of course, they are the choice, and they are going to select the best choice for them. Safety comes first. So in 2011, we are ready to mass produce EV, whereas it's in North America, it's in China or another low-cost country. Economy of scale through low-cost raw materials and automatization of manufacturing. You have no choice for batteries to use low-cost material, available materials too. Of course, there will be a recycling system at the end of the life of the car. OEM looking for the safest, efficient, and reliable rechargeable batteries available on the market, as mentioned. And there is a tough competition between the big players. Money, millions of dollars of profit for the EV industry. So thank you very much for your attention. And if you have any questions, I will be happy to answer to them.